Hi students, in the previous videos we have learned about the general design procedure of the assemblers, and the next section, the continuation part of the chapter 3 is the topic is table processing, that is searching and sorting techniques we are going to learn. Okay, so now in this video we are going to learn the searching technique, the linear search. Okay, now let us see. Okay, this is what the explanation about the linear search. This is the explanation given in the textbook. Okay, and this is the explanation or notes given to you. Okay, so let us learn about the linear search. Now here they have mentioned that this search technique can be applied to the array elements which are not in order. Okay, that means with the elements which are not sorted. Okay, so now even though the elements are not sorted in the array, we can apply this linear search. Okay, now let us see here linear search. Linear search is also known as sequential search. Why it is called as a sequential search means we are going to take a one key element, and that key element is present or not in the array list. We are going to search one by one sequentially. Okay, so first the key element is compared with the first element of the array. So if it is not found, then second element of the array. If it is not found, third element of the array, and so on. Okay, so until it will get the array element, it will be go on searching for the key element in the array. If there are n elements in the array, uh, in the best case, the key element is found in first comparison. Okay, and in the worst case, it takes n comparison. Okay, and best case occurs when the key is at first position. If our key element is present in the first position itself in the array, that is the best case of that searching technique. Okay, then if in the worst case the key element is either at the last position or not present in the array, that is called as a worst case of that linear search technique. Okay, now let us look into the algorithm. So now the step 1, set the index value to 1. Okay, and step 2, if I is greater than n, then go to step 7. So what is there in the step 7? Print element not found. Okay, so now that means if n I is greater than n means it has taken the number of steps more than the number of elements. That means it has compared with all the elements, then also the element is not found. Okay, now the step 3 is if a of I is x, then go to step 6. Okay, now that is print element x is found in the index I, and go to the step 8. Step 8 is exit. Okay, and this is also the simple algorithm of the linear search. And if we see here, it will give the both the advantages and disadvantages of linear search. Okay, here clearly mentioned that linear search procedure is fine for short tables and has the great virtue of simplicity. Okay, if there are less elements in the array, then it is very good to use the linear search, but for long tables it can be very slow. Okay, so now for more number of elements are there means it will be very slow to identify the element in the array. Now let us see how the linear search will work. with the example. Now this is the given array. The array name is A. Okay, so these are the array elements. Okay, the starting index is 0. Okay, now array consists of 8 elements. Okay, the array element to be searched is called as key. Okay, key is 10. Okay, now we have to search this array element, the 10 element we have to search. Okay, that is assigned to the variable key. Now now key element is compared with the array elements to check whether it is present or not. Okay, means this element is the key is compared with a of 0. Okay, now key is equal to a of 0. A of 0 is what? 80. Is equal to 80? No. Then it will be, I will be incremented by 1. Now a of 1, what is 40? If key is equal to 40? No. Then again incremented. Okay. So like this algorithm will be worked. Okay, while searching, it will check with the index a of 4. Now key is equal to 10. Yes, now 10 is equal to 10. The element is found. Then that particular the position is returned. Okay, so now after returning the position, we will come to know the element is found in that particular position. This is what the here the explanation is given here. Okay, now let us see what is the best case, worst case and average case of this linear search. The best case is searching a key element present at first index. Okay, that means best case of n elements means omega of 1. That is, that means omega of 1 means this is nothing but the time complexity of the best case of the linear search. Okay, then what is the worst case time complexity of the linear search means omega of n means it is taking the n number of comparisons. Okay, and you can say the number of elements. If the number of elements are 8, means 8 comparisons it is taking. That is the worst case of the linear search technique. Okay, now what is average case time? So means all possible case times divided by number of cases. That is nothing but average case time. Okay, so that's it about this linear search technique. In the next video we are going to learn about binary search. Thank you.